Now that we've seen the limitations of traditional systems engineering, let's see what makes MBSE such a big deal. The official definition states that MBSE is the formalized application of modeling to support system requirements, design, analysis, verification and validation activities, beginning in the conceptual design phase and continuing throughout development and later lifecycle phases. So MBSE emphasizes the creation and use of models to support systems engineering activities. Before we dive into all the exciting details, let's start with the basics. What is a model? A model is like a simplified version of reality. It's designed to capture and highlight some features of reality, while leaving out unnecessary details depending on the scope of the model. It's not the full thing, but it's enough to help us understand how things work. For example, a helicopter exists in the real world, it is our system. A model can be the flight simulator, which emulates flight characteristics to train pilots, a 3D model of some of its components, or a conceptual model to understand what is the helicopter role in a search and rescue mission. These models are powerful. They let engineers and stakeholders visualize, communicate, and analyze complex systems without the need to build the entire thing first. It's like having a virtual prototype before you even touch the physical world. No more guesswork, just solid data and insights. Over the last 30 years, we've seen a paradigm shift across engineering fields. Take mechanical engineering, for example. In the past, engineers worked with 2D drawings, think blueprints and flat sketches. But then, along came 3D modeling, and it revolutionized the design process. Engineers could now visualize the designs, simulate real-world conditions, and test before building a physical prototype. The computer-aided design made it all happen, and it transformed the game. And now, systems engineering is undergoing a similar shift. Just like how 3D replaced 2D in mechanical engineering, documents produced by systems engineers are being replaced by system models. Today, documents produced by systems engineers are the source of truth, and it tempers with our ability to manage complexity. With MBSE, these documents are replaced by a system model. It is a digital version of the system. It can be both descriptive and analytical, and it ties everything together, from requirements and designs to analysis and verification. Remember the chaos of brains and documents from earlier? Well, with models, this is how it looks. All engineering data is integrated into the system model for everybody to access. It's always available, and more importantly, up to date. At least in theory, but we'll see about that later. Let's revisit the characteristics of systems engineering, but from a model-oriented perspective. The activities are still the same, from concept definition to system validation. But instead of documents, we use models. As the system evolves, so does the model. It's constantly updated, integrated, and refined throughout the activities performed, ensuring that it always reflects the current state of the system. Model-based systems engineering, just like document-based systems engineering, is iterative, meaning the model is updated as we discover new elements in the later activities. Then, recursion. We simplified and talked about a singular system model, but in reality, it's not a monolithic model. It's a collection of models. Systems engineers at different levels each have a model of their system following the systems engineering process, and they're all connected. When one gets updated, the others reflect those changes. But this is just the systems engineering part. The real power of MBSE comes when the system model connects with other engineering disciplines such as electrical wiring models, 3D models, and so on. And finally, concurrency. Remember that in complex projects, different parts move at different speeds, and you've got lots of teams working in parallel. Well, the system models follow the life cycle of each part of the project. Some begin earlier, some later, and they live as long as the project needs them. And this is where it starts getting tricky with MBSE. How do you manage all those models which needs to be integrated? Well, the same way you architecture a system, you must architect your MBSE machine. You could even use MBSE for that, applying MBSE on MBSE itself. But let's not get ahead of ourselves. This is a topic for another day. Back to basics. Now let's talk about the three pillars of MBSE: method, language, and tool. First up, the method. The systems engineering process defines what activities to be performed. The method defines the how. It outlines the workflows and procedures to follow throughout the lifecycle of the system. It makes sure that everything is structured, organized, and consistent. Examples of methods include the Airbus MOFLT, Arcadia, or Magic Grid from Dassault Systems. Next, the language. This is how we represent the system in a standardized way. The most widely used is the system's modeling language, SysML for short. But there are others like BPMN, which stands for Business Process Modeling Notation. The language gives everyone a consistent way to communicate the system's structure, requirements, behaviors, and interactions. This makes sure that all stakeholders understand the system in the same way. No more misinterpretations. Finally, the tool. This is the software or platform used to create and manage the system models. Tools like Magic Cyber Systems Engineer, Capella, or Mega Hopex support different languages, and they help you visualize and interact with the system models. They are key to making the whole process faster and more efficient. All three pillars are interdependent. One must not buy a tool without thinking about the model's purpose, because each tool shines in different areas. Methodology, language, and tool choice shall be justified versus the systems engineering activities you want to cover. To conclude, we would like to emphasize on something crucial. Modeling is a means, not an end. A model and all the infrastructure behind it must have a purpose. It must be clear what systems engineering issues it aims to tackle. That means that you must think about the clear boundaries for your models, about which model will serve what purpose, and find a way to assess the maturity of your modeling effort. This is key if you want MBSE to bring the value it promises.